Hello, today we'll do Cambridge A level for further maths syllabus code 9231. This is the paper 2, the further pure 2 paper, variant 1 from the May June 2025 series. We start with question 1, which is a complex root situation. So we have a complex cube given 27 minus 27i, and we want to get the roots of this in the form r, yeah, I mean the exponential imaginary form, and they're also given the boundaries that r has to be greater than 0, and also that theta is in between negative pi and pi. So maybe first let's try and express this complex number as the exponential form. If you recall your Argand diagram, where this z cube will be is somewhere here, where it's a 27 on the real axis and negative 27 on the imaginary axis. So to find the r, which is the length or the magnitude of the kind of the line, right? We can use the Pythagoras theorem. So r, that will be square root of 27 squared, 1458. So I'll just leave it like that for now. It doesn't say I have to find in exact, right? So it's okay. I'll just leave it for now. And to find the angle, the theta, first of all, is from the positive x-axis, but it's turning clockwise. So we will have, first of all, is a negative, and we're also going to have a tangent, 27 over 27. Okay, that will be tangent 1, which you can recall from your 45, 45, 90 triangle, is 1, 1, square root 2. So at the 45 degrees, the opposite and adjacent is 1. And yeah, therefore the answer for this will be negative pi over 4. 45 degrees is the pi over 4 radian. Okay, and so z cube, that will give us r, which is the square root of 1458, e to the power of theta I. Okay, and z cube also, we know z cube can be presented in the form using the de Moivre's theorem, right? Let's say z is also z is obviously is going to be an imaginary number, so let z be a plus bi, and therefore it's also some form of in this form, r e theta I, and z cube using the de Moivre's theorem, right? Z cube, I cube the whole thing, therefore it will be r cube e3 theta I. Okay, so this is de Moivre's theorem, de Moivre. And yeah, now we can equate these two. These two, right? We have the ones with our value and the ones from the de Moivre theorem we can equate. So 1458 square root is the same as r cube e3 theta I. And of course, we know that this is not really complete, because we know that there is infinite or infinite equivalent answers to this, because every time we spin 2 pi radian, you will get the same answer also. So either way, we have to add 2 pi n to one of these, but we'll deal with that solution later. First, we can deal with the r. The r, that will be or r cube, that will be equivalent to 1458. So r will be 1458 to the power of 1 over 6. Okay, and then for next, the theta part, again, once we've established this one, negative pi over 4 equals to 3 theta. But yeah, we're not it's not complete, because we also have to add this term 2 pi n, because again, there's an infinite number of solutions to this. Okay, and we want, and that for this particular question, we have some boundaries to deal with. So and it's a z cube also, z cube power of 3, meaning there will be three different roots. So yeah, let's deal with this. theta, after we simplify everything, we have this expression. So we probably want to get yeah, we want to try the n values for which it satisfies the theta uh their boundaries lah. Okay, so maybe we try 0 first. When n is 0, we have just negative pi over 12, and that's within it. So let's go for negative 1 so that we can clear the negative part first. So if it's negative 1, it will be negative 3 over 4, right? Negative 3 over 4. Yeah, negative 3 over 4, which is also within our boundaries. So I think if we go to negative 2, there will be definitely less than negative pi already. So let's try n equals to 1. So theta, in this case, n equals to 1, that gives us 7 pi over 12. Okay, so yeah, I think that's enough because we only want three boundaries, and if we get n equals to 2 is also probably outside the boundaries. So yeah, we have three z values, which will get 1458, 106 pi over 12 I. Second one, same r value, but the data is different. And the last one also, 1458 power 16 and 7 pi over 12. So yeah, three answers for a cube complex number roots.